Hello, I'm Jackie Sack. I'm an assistant professor at the University of Houston downtown in the Department of Urban Education, where I teach mathematics methods courses. Thanks.
Nice.
Thank you. And you.
That was cool. Y'all so y'all can just take these and just stick them on top and keep making different shapes.
Yeah.
And I'm Michael Connell. I'm a professor in the same department. I also teach math education.
Using kite material. So these were manufactured by a kite manufacturer, and basically it's the seams over here are just black hollow seams that have hollow carbon rods down them, and then this is just a nylon thread that passes through the carbon rods and ties together, and that's what holds the triangles rigidly. So I have had a set of these triangles for over 10 years with lots of use, and they're still in perfect condition. The mini grant that we just received allowed us to purchase a second set, and we're ever grateful for that.
I would, being the recipient of the second set, I would like to express my gratitude also. The enhancement this adds to the methods courses is significant because it allows my students to experience the mathematics in a different way. As adults, very rarely do we have the chance of getting the aha that our young children have when they interact with hands-on materials. And this is such a unique manipulative material that they can construct some personally meaningful mathematics in a way that they probably haven't done since they were young children themselves.
The other plus about this, just from a general methods perspective, is that we're also trying to model highly interactive, collaborative activities. And this one particularly lends itself to that because no one can be the boss of the construction. They are extremely dependent on each other in order to complete the required activity.
Right.
So it's a really good modeling experience for them in seeing how mathematics can be built.
There are literally thousands of activities that could have been done from the same starting point, but each of them would share the same family resemblance. We'd develop our vocabulary, we'd have actions, we'd build meaningful mathematics through our guide of the organization, and when we have a record of action, then that becomes a point we can come back to reestablish and formalize the mathematics. Well, you know, the question of why would a math educator want to use these, to me, kind of raises why wouldn't they?
How does this connect to those important CCRI standards? So for one thing, we are looking at figures and their properties, as you will see in the main presentation, looking at the properties of 3D figures in terms of their faces, vertices, and edges.
It also seems very natural to go into transformations and symmetry. As you'll see in the main presentation, symmetry is very important when it starts time to count the faces, the edges, the vertices.
And that is the connection to the other mathematical strands.
And so we're generating a 1, 3, 5, 7, 9 number sequence. Well, it's not obvious why. You have to interpret, you have to connect the different strands of mathematics to get to that.
And the representations are verbal, they're oral,
graphical,
they're graphical,
physical,
they're tabular,
functional,